Okay guys, with the SAT coming soon for me on August 24th of this year, we're gonna do a quick 4-video series on each section of the SAT. I'm not gonna get into the essay because that's pretty easy to do. You just need to look online for, fill in the blank samples. It's pretty easy to just look up online, just fill in the blank ways of writing the essay, and the essay isn't even really required. It's optional. A lot of colleges don't actually even look at your SAT essay, so we're just going to focus on the 4 sections of the multiple choice part of the SAT. And so we'll start off our 4-video mini series with math with no calculator. Although it's not the proper chronological order of the test, this is the one that I feel has the least number of strategies because it's the least number of questions. And so it's probably the one where it's you just gotta come up with ways of trying not to waste time. That's the most important aspect of the SAT, is to try and not waste time. For all the sections, but especially for the math with no calculator section, because it is relatively short, only about 25 questions, and it is also only about 25-30 minutes, I believe. That's it. Only 25-30 minutes. And so it's really quick. You only have about 1 minute per question, I would say. It would be around there, right? So based on that, I've come up with a few time-saving strategies for you, and here is the document for that. You can find the link for this in the description. Okay? Just a few strategies. So there are 5 strategies here. Okay? And so the first one that we have is plug and chug. And so what does plug and chug mean? Well, plug and chug means that it is, you take the multiple choice answers that you're given, and then you plug them in to the question to see whether it fits the question properly. And if it does, then that's the correct answer. If it doesn't, then that is not the correct answer. Normally, when you solve questions like this on your math test, you would have to solve for the correct answer, then plug it back in to see if you got the correct answer. Okay? What we're doing here is we don't have to do that. We're given the answers. It's multiple choice. All you need to do is you can skip that first step, and then you can go right into doing that second step, which is plugging it in and checking your answers. Since the answers have already been made available to you, all you have to do is just utilize them. Okay? So here is the sample question. I didn't include any of the answers on this document, so you have to watch this video in order to actually see the correct answers. Okay? So the first question that we have is, what is the value of x? What value of x makes the following true? And this is the system of equation. That is the equation. X plus 3 over 2 equals x minus 2 over 3. So how would I possibly solve for this one right here? Okay? Well, and here's just the question with the answer choices, alright? So you can see that. You should probably already have it up on the document, but just in case you don't. Alright, that is the question, and we're going to try and solve this question, okay? By using plug and chug. So our answer choices are 13, 10, negative 13, and negative 5. Okay, so these are our answer choices: 13, 10, negative 13, and negative 5. So what we do when we plug and chug is we start with A and we go down to D until we get the correct answer. So let's plug in A. 13 plus 3 over 2. So that's 16 over 2, so that's 8. Okay, so that's 8 is equal to 13 minus 2 is 11, 11 over 3. Those are definitely not true, so this one is wrong. Okay. 10, so B is 10. So 10 plus 3 over 2, that's 13 over 2. That should be equal to 10 minus 2 over 3, which is 8 over 3. You can see that this is definitely not true, right? So this is also incorrect. Negative 13. Negative 13 plus 3 is 10. Divided by 2, you get negative 5. Negative 13 minus 2 is negative 15. Divided by 3, you get negative 5. Oh look, negative 5 is equal to negative 5. So this one is our correct answer, and we are done with the question. See, if you didn't do that, what you would have to do is you would have to solve for it. Multiply both sides. Multiply this side by 2. You get x plus 3 equals 2x minus 4 over 3. Multiply both sides by 3. You get 3x plus 9 equals 2x minus 4. Then solve for x. So subtract 2x there. You get x. Subtract 9. You get negative 13. Like that, okay? So that's what you would have to do. Versus, and then after you solve for it, you'd have to plug it back in. Okay, negative 13 plus 3 is negative 10 divided by 2, negative 5, and so on, right? See, what we're doing here is all we did was we just plugged it in, we checked, and we're moving on. Okay? And it actually saves a lot of time. Alright? Because here's the thing. Although it could be D, right? It could take you all the way down to the last answer choice, right? What you do know is that if you eliminate the first 3 answer choices using this method, you know that the last answer choice has to be correct, because one of them is correct, okay? And only one of them is correct. So in that case, if you're able to eliminate the first 3, you know the last one is true. You don't even need to plug it in. Just move on. Just mark that one is right, bubble it in, move on, or whatever, okay? Oh, and by the way, regarding bubbling in, a general strategy is that you should only bubble in after you complete a page of the page of questions. Don't answer a question and then bubble in, or answer all of the questions and then bubble in, because then you're wasting time. If you do one page and then bubble those questions in, then move on to the next page, then bubble those ones in, then you're not pressed for time for bubbling in quickly, because sometimes that might lead to your bubbles being improperly marked, or and then that could invalidate your score for that question. Okay? So we found our answer there. All right, don't even need to check the last one, because we found the correct answer, and we're moving on. So our next strategy is substitution. So if you've taken algebra, you've probably heard of substitution. So substitution regarding the systems of equations, right? Is you solve for one variable, plug it in. Is you solve for a variable, plug it into another equation, and then solve that one to solve for both variables, and so on and so forth. Right? So this can actually make it easier for you if you know when to apply the proper system of equation strategy. Okay? What I see most often is that the questions that most people have trouble with on the SAT Math with No Calculator section are these systems of equations questions, okay? So we're going to go over a sample SAT with no calculator question regarding substitution. And so here's the question right here. Okay? All right, you can look at it on the document in the link below. So our question is, so our system is 3. Okay, and then okay, so we need to know when to apply substitution. So we know we have 2 possible strategies we can use: substitution or elimination. Which one should we use here? Well, h is already easily defined for us. Even if it were 3 times k plus 2 minus h equals 0, we could still easily solve for h by moving h to the other side, okay? As long as it's easy to move h to the other side, then you're good. And so what you can do here is, this is also easy to isolate h as well. Just multiply both sides by k, so you get h is equal to 5k. And now you've just set both sides equal to h, so now you can just set them both equal to each other. So you get 3 times k plus 2 is equal to 5k, okay? And the question is even asking, what is the value of k? So we've already done this, right? We've eliminated h, although we're not actually using elimination, we've eliminated h from the system of equations through multiple substitution in this case, all right? And then we've gotten 3 times k plus 2 equals 5k, so we get 3k plus 6 equals 5k. And then we subtract 2k from both sides, 3k from both sides, my bad. Then you get 2k is equal to 6, and so you get k is equal to 3. Or you can do it another way. So say you just leave it in terms of h over k is equal to 5, and then you have h is equal to 3 times k plus 2. In this case, what you do is you just pass this into there, and so you get 3 over k plus 2 over k equals 5. Multiply both sides by k, and then you get 3 times k plus 2 equals 5 times k, like we did here. All this is we're just, instead of moving things over already and then doing the equal to each other, we're just automatically substituting it in, okay? And so when to use substitution? When you can easily isolate a variable. If you can easily isolate one variable in a system of equations, you should use substitution. If it's not as easy, okay, like you have to rearrange a lot of things, then you should use our next strategy, which is elimination. So elimination is exactly what the name entails. So elimination is to eliminate one variable from the system of equations by adding up all the system of equations, okay? So in our sample question, what we have is this right here. So this system of equations right here, okay? It's in the document below, all right? Make sure you check it out. So our system is 3x plus 5y equals 15, and then we have 5y minus 3x is equal to 5. Okay, so what we know here is that if we add both together, we can easily just eliminate x as such if we add like that. And when we add, we're doing 3x plus negative 3x, we get 0. 5y plus 5y, we get 10y. And then 15 plus 5, we get 20. So then we get y is equal to 2. But then it's asking what is the value of x. So then we have to plug y2 back in. So we get 10 minus 3x equals 5, or 3x plus 10 equals 15. And so we know that 3x is equal to 5. And so in that case, x must be equal to 1 2/3. Okay? Or we can just, instead of eliminating x, because that's what we're supposed to be solving for x, right? So we should eliminate y instead. Alright? And that's also pretty easy to eliminate as well. And why is it easy to eliminate? Well, because all we need to do is just slap a minus sign on there instead of a plus sign. And then so when we're doing a minus, subtracting is just the operational opposite of addition. So we just add the opposite, like that. So we just replace any positives with negatives, negatives with positives. All right? And so basically we end up with 5y minus 5y, 3x plus 3x, 6x, 15 minus 5, 10. So we get x is equal to 10 over 6, which is equal to 1 2/3. Boom. Automatically done. No need to substitute y back in. So those are your two options for when you do elimination. You can add, and you're solving for one variable. Sometimes when you're doing elimination, you need to solve for both variables or all variables. But in this case, we're just solving for one. And since it's easy to do either way, it's your decision, whatever is fastest for you to do. Here is our sample question. Kind of hard to read quickly. You'll either have to pause or just visit that link in the description below. So our strategy is called keywords. So in this case, we're just using word-based prompts. So what is a word-based prompt? It's just a word-based question, passage question. You're not really given like equations. You're given words and just a few numbers here and there. All right. It's what elementary schoolers and I guess maybe a few middle schoolers would refer to as word problems. All right. So that's basically what these are word problems. So this is a strategy for word problems, keywords. So you take those keywords such as per, for each, and, below, total, part, whole, only, with, without, and etc. Just so on and so forth. Just any keywords like that, any operational keywords and other things like that. Those are marking those as you read the question are going to be very helpful for you. So our sample is the epipelagic zone, is the oceanic zone, all right, that extends from the surface down to a depth of approximately 650 feet below sea level. So 650, so we're just going to write off to the side because I'm not going to write on the paper. Of course, I don't have a pencil or pen with me. I have this Expo marker, all right? What you're going to do is you're just going to underline. On your SAT, you're allowed to write wherever you want, whatever you want, okay? So, no, because no one's going to look at it. So go ahead and do whatever you want. Take as many notes as you want. It'll actually help keep you focused if you have your pencil moving all the time. Help keep you from falling asleep, because I know you got to take the SAT at like, what, 8 in the morning? I know, it's really early. Yeah, so I'm just going to jot down our keywords here. So our first keyword we see is 650 below. So when we see the word below, we can automatically say this is below sea level. If we represent sea level as a value of 0, then this is also equivalent to negative 650. Okay? Let's keep reading. At a depth of 170 feet below sea level, the total pressure is 90 pounds per square inch. Okay, so then we have 90 lb at. So then I'll add this to the 170, right? So these go hand in hand. Okay. And then at a depth of 200 feet below sea level, 15, the total pressure is 110 pounds per square inch. For every additional 5 feet below sea level, so it says additional 5 feet, and it's below, so it's negative 5 feet. Below sea level, the total pressure increases by p feet, by p pounds per square inch. Where p is a constant, what is the value of p? Okay, so now that we're given the question, what is the value of p, what we need to do is we need to use the information that we're given to create this. So our keywords are, we have this 650 below, 170 below, 90 pounds below, 215 below, and 110 pounds per square inch, 90 pounds per square inch, additional 5 feet below, p pounds per square inch. Those are all of our keywords that we have there. So how can we approach this question? Well, using these keywords that we've gotten, 650 below, 170 below, yada yada yada, we can approach this question by creating something akin to a mock equation, okay? So if we know that at 170 below, the total pressure is 90 pounds per square inch, right? And at 215 below, the total pressure is 110 pounds per square inch. Where did that ratio come from? If p is a constant, and so forth, then we know that this is modeled by some kind of equation, right? Because we know that this is modeled by some kind of equation, then we can approach it through that means, all right? And so how did we know that this is going to be modeled by some kind of equation? Because we've written down all of the key words, we know what it is we're going to need and what we're going to use, okay? Now, first thing we can do is we can eliminate some keywords. This one we can eliminate. 650 isn't going to provide us with any information because we're looking for pressure, and there's no pressure that is paired with 650 feet below sea level, okay? Nothing is paired up with that, so that means that this is irrelevant. We can eliminate it. We don't need it anymore, all right? So now we're with these three things, and all of these actually have pressure values attached to them, so we know that they're important and we can use them. All right, so let's start off with what we know and what we need to know. So we're trying to find P. We know these two pressures and we know these two distances below sea level between them. So let's map it out, all right? So if I draw the actual sea level like this, all right, not to scale, of course, this is 0. This is our negative 170, this is our negative 215, and this is our negative 650, okay? So we know that the pressure, so as this increases, we know that the pressure increases by 5 after this, okay? But we don't know the pressure here, so how can we solve for P if we don't know the final pressure? Well, we can't solve for P if we don't know the final pressure, and we use this value. So we can't use this method. And why is that? Because we don't know any pressure associated with this, so we can eliminate it. Then, you would say, okay, but I know the pressure with these two, so I can do this, right? But I don't know the initial pressure, right? Because I don't know the initial pressure, I can't use this either. So, knowing that we have a sea level is useless to me as well. So this is the only solution we can come up with, is finding the difference in pressure between these two distances below sea level, 170 and 215. So knowing that, what we can do is we can figure out the distance between this. Negative 215 to negative 170 is 30 plus 15. That is 45. So that's 45 feet of difference, all right? So we have 45 feet of difference. If we know that P increases for every additional 5 feet below sea level, then we can divide this by 5, the 5 that we have here, right? And so it's actually negative 45 feet of a difference. And we divide that by negative 5, right? Then we get 9. So we get 9 iterations of P. What does that mean? It means 9 times P. Okay, so in that case, we know that the answer is there's a 9p pound per square inch difference of pressure between 90 and 110. That means that 110 minus 90, we know that's 20. And we know that that is also equal to 9p, so p has to be equal to 20 over 9. And there you have it. That is how we solved our question. I used the information I knew, using my map and using my keywords, and I found 9p, then I used what else I knew, and then I used that to figure out what the value of p is, and I discovered that it is in fact 20 over 9, okay? And the last strategy that we have here is just use the reference. And I'm not going to actually explain what that is, you're going to have to read the document. So thank you for watching, and I'll see you in the next SAT prep video.